Probando, uno, dos, sí. Hola, 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 hola.
A lot. Or people say to me all the time, like, so I want to learn blockchain development, but I don't know where to start. All right, I've heard this a lot. Or people say to me all the time, like, hey, you have so many YouTube videos out there, like, which one do I start with? I totally get it. You know, it can be really overwhelming. So what I've done in this video is created the best starting point for learning blockchain step by step in 2020. I've taken some of the
Buenas, Germán. ¿Qué pasa? ¿Cómo lo llevas? Espero que te encuentres bien.
videos from my channel and combined them so that you can follow a step-by-step plan. So before we get into that, if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. And I've worked really hard on these tutorials. So if you can do me a huge favor and smash the like button down below for the YouTube algorithm and also subscribe to the channel, that really helps these videos get found, all right? And if you like these tutorials and you want to take the next step, or hey, maybe you want to take a massive shortcut entirely, then head on over to dappuniversity.com/bootcamp to get started today. So let me tell you how to use this video. You can find a table of contents down below that will help you navigate through it, but let me give you the bird's eye view. First, I'm going to give you a really quick introduction to what blockchain is and how it works. I think that's necessary before you really do anything else. But then we're going to jump straight into building a project, even before you know all the programming languages. You're actually going to learn them as you go. And I think this is the best way to learn because it gives you purpose and it's more efficient. And then after that, we're going to revisit the finer points of the programming language and explore them in depth once you've gotten your hands dirty. And by the time you've finished, you'll be surprised at how much you've actually learned. And so
Me alegro que te encuentres mejor, tío.
I highly recommend following this format, especially if you're brand new. But if you want to bookmark this video and come back to it, then definitely check out that table of contents down below to help you move around. All right, with that being said, let's get started. So what is a blockchain? Well, to answer this question, let's look at how a normal web application works. Normally when you use a
¿Se escucha bien el
web
vídeo?
application, you access
Muy
it with your
fuerte, muy
browser,
flojo.
and that web browser talks to a central server. This server hosts all the code for the web application, and all the data is stored inside of a central database. This presents a real problem. You can't store value this way. For example, you couldn't create a digital currency with a traditional web application. Why is that? See, the code could be changed by the developers at any time, and the data in the database could also be changed arbitrarily with anyone who had access to it. This means that whoever controls the money could manipulate your balance and steal your funds. So we don't want to use a centralized web application to create money. Instead, we want to use the blockchain. It will guarantee that no one can change the code for the application or manipulate the database. We can rest assured that our money will always work in a predictable way and that our funds won't be stolen. How can we achieve this, you might ask? To answer this question, let's look at how a blockchain works. A blockchain is basically just a giant worldwide computer. Instead of a single computer that stores data and runs programs, blockchains use thousands of computers that all handle this. Each computer is called a node, and each node talks to one another. And each node also gets a copy of all the data and all the code that's stored on the blockchain. All this data is stored in bundles of records called blocks, which are chained together to make up the public ledger. And all the code is stored in smart contracts, which are immutable code that runs in the blockchain. This creates endless possibilities for a new generation of applications, not controlled by anyone, but instead run by themselves on the blockchain. Cryptocurrency is a great example. You can create a cryptocurrency with a blockchain because each node in the network is responsible for processing your transaction and tracking your balance. Whenever you send cryptocurrency, the network achieves consensus that your transaction is valid and that your balance is updated properly on the public ledger. Now let's look at how a basic blockchain application, or a dApp, works. For this tutorial, we're going to use the Ethereum blockchain. To access the application, you'll use your browser to connect to a front-end website written in HTML, CSS, and JavaScript. And instead of talking to a back-end web server, this website will talk directly to the blockchain. This is where all the code and the data for the application will live. The code is contained in smart contracts, which are written in a Solidity programming language, which looks a lot like JavaScript. These smart contracts are immutable, which means they cannot change. And all the data is stored inside of transaction records on the public ledger. And all the data is stored inside of transaction records on the public ledger, which is also immutable. Anytime we add new data to the blockchain, it will be permanent and publicly verifiable. So that's an overview of what a blockchain is and how it works. Now let's get a preview of the application that we're going to build together in this tutorial and see how it leverages the power of the blockchain. This is an instant cryptocurrency exchange called ETHSwap, where you can trade cryptocurrencies at a guaranteed price. You can buy and sell cryptocurrencies immediately without having to open any buy or sell orders or wait for anyone else to fill your orders. Inside this application, we're going to trade two different cryptocurrencies. The first is Ether, the native cryptocurrency of the Ethereum blockchain. And the second is dApp token, a cryptocurrency that we'll create together in this tutorial. Our applications will allow us to purchase dApp tokens with Ether.
Se viene Sensio Coin. ¿Estáis preparados?
Like this. We'll just specify the amount that we want to purchase, click swap, and we'll see our dApp token balance go up. And we'll also be able to sell the dApp tokens in a different tab like this. And you can see that the cryptocurrencies change here. And we'll also highlight the redemption rate, the price, right? And then also the account that we're connected to on the blockchain, along with an identicon that represents the user's avatar. Here's a diagram of how the application will work. We'll build a client-side application in React.js. That's what you see here. And then this client-side application is going to talk directly to the blockchain, all right? And then the blockchain will contain two different smart contracts. The first smart contract will be the ETH swap contract that facilitates purchasing tokens and also selling them. And then that smart contract will talk to a second smart contract, which will be the token that we create in this tutorial. In this case, the DApp token. The first is Node.js. You can see if you have Node already installed by going to your terminal and typing node-v. If you don't have Node installed yet, you can install it with a command line tool like Homebrew, or you can download it directly from the Node.js website just like this. For this tutorial, I'm going to stick with Node version 9.10.0, and I suggest that you do the same. The next dependency is Ganache. This is a one-click blockchain that runs on your computer. I'll put a link down in the description below where you can download this. But when you go here, you can just click this download button and it will automatically select the correct installer for your operating system, whether you're on Mac, Windows, or Linux. And once you've downloaded it and you start it, you'll have a blockchain running on your computer. And you can see that it gave you 10 accounts for free. And each of these accounts has been pre-funded with cryptocurrency in their wallet. So in this case, it's Ether, or the native cryptocurrency of the Ethereum blockchain. That's what this represents. And this cryptocurrency isn't worth anything. This is just pretend cryptocurrency for development purposes.
Blockchain es el futuro, Germán. Hay que darle duro. A ver, me ha dicho que me descargue Ganache. Ganache. A ver, ¿esto qué es? Quickly fire up a personal Ethereum blockchain, which you can use to run tests, execute commands and inspect state while controlling how the chain operates. Vale, o sea que esto, Ganache, nos va a poner una blockchain en nuestro ordenador. Bueno, no está mal. Descarga. Instalar Ganache. Instalar. El Sabadell y el BBVA ya lo utilizan para transacciones seguras y privadas. No sé, yo no tengo casi nada de experiencia con esto, por eso quiero aprender. Compré algunos bitcoins hace tiempo, pero vamos, bueno, algunos bitcoins, muy pocos. 20 euros o así. Vale, Ganache, esto ya se ha instalado. Ganache includes Google Analytics. No. A ver si os lo puedo enseñar. Captúrame, Ganache. Lo veis, ¿verdad? Esto es lo que me ha instalado. Quick Start for a one-click blockchain or create a new workspace. Quick Start. Espero que no haya por aquí ninguna cosa para que me hackeéis el ordenador. Gas price, gas limit. No lo veis y no lo puedo hacer más grande, ¿no? Bueno, por lo que he entendido del tutorial, esto nos acaba de poner una blockchain, o me acaba de poner una blockchain en mi ordenador, de Ethereum, con 10 cuentas de prueba y cada una tiene 100 Ethers. ¿Cuánto vale esto? Un Ether son 2000 pavos. Nada mal.
But you can see the account's address here, and then also you can click this to reveal the private keys. And finally, I'll say don't use these accounts in the real world because everyone who's watched this video has seen these private keys, and you don't want to compromise your funds. The next dependency is the truffle framework.
Ahí ha dicho algo de que me hackeáis, ¿verdad?
Currency isn't worth anything. This is just pretend cryptocurrency for development purposes. But you can see the account's address here, and then also you can click this to reveal the private keys. And finally, I'll say don't use these accounts in the real world because, everyone who's watched this video has seen these private keys and you don't want to compromise your funds. The next dependency is the truffle framework. This is a smart contract development framework where we'll be able to create Ethereum contracts with a Solidity programming language. We'll also be able to write tests against the smart contracts and deploy them to a blockchain. I'm going to use a very specific version
Hola Lázaro, bienvenido.
of truffle in this tutorial, and I suggest
Estamos aprendiendo a hackear la blockchain.
that you do the same. I'm going to go to my terminal and type in npm install --g truffle at version 5.1.1.
Me va a pedir ahora que me instale esto, ¿no? ¿Qué estás haciendo exactamente? Crear tu propia blockchain. Estamos aprendiendo sobre blockchain. De momento me he instalado un programa que se llama Ganache, que me ha montado una blockchain en mi ordenador para hacer pruebas. Y ahora me voy a instalar esto de aquí, Truffle, que en principio me va a ayudar a desarrollar programas para la blockchain. Pero bueno, vamos a jugar, vamos a hacer cositas así tontas. Me gustaría hacerme una criptomoneda, si se puede. Pero más que nada por las risas. Esto ya nos lo hemos descargado, el Ganache. Ahí más blockchain igual a mucho dinero. Bueno, la parte de la I ya la tenemos. Así que... Truffle, Smart Contracts Made Sweeter. Entorno de desarrollo y testing de Ethereum. Vamos a probarlo. Ha dicho npm install global npm i-g trufa. Lo llamamos trufa. O cuando el Sensiocoin valga millones, seréis ricos.
Click enter. And finally, we must install MetaMask. This is a browser extension that will turn our normal web browser into a blockchain browser. You can go to the Google Chrome Web Store to find MetaMask and just click install. I've already done it, so I have the remove button, but if you don't have it yet, you should see the install button. All right, and once you walk through the setup steps, go to your Chrome extensions and make sure that you have MetaMask enabled. You can tell that it's enabled by seeing the Fox icon up in the right-hand corner of your browser. Now let's start building
Chrome extension MetaMask. A crypto wallet and gateway to blockchain apps. Buy, store, send and swap tokens. Ok, añádamelo a Chrome. Ah, ¿qué hace? Bienvenido a MetaMask. Conéctate a Ethereum y la web descentralizada. ¿Es nuevo en MetaMask? No, ya tengo una frase semilla. ¿Importa tu monedero existente? Sí, esto creará un nuevo monedero. Y frase semilla. Esto me da que lo voy a quitar de aquí. Os dejo con el vídeo pausado. Ayúdanos a mejorar MetaMask. No, gracias. Vamos a crear una contraseña. Me está dando ahora frases secretas y cosas que obviamente no quiero que veáis. Ahora me está diciendo que las escriba. Enhorabuena, todo listo. El intercambio de tokens ya está aquí. Vale, os lo traigo otra vez. Espero que ahora no salga ninguna cosa privada. El intercambio de tokens ya está aquí. Ahora puedes intercambiar tokens directamente en su monedero MetaMask. Intercambios MetaMask combina múltiples agregadores de intercambio descentralizados, creadores de mercados profesionales y DEX individuales para garantizar que los usuarios de MetaMask siempre obtengan el mejor precio con las tarifas de red más bajas. Uniswap Totle, Paraswap, Tax, AirSwap. Pues muy bien. Comenzar intercambio. Intercambiar. ¿Alguien sabe algo de esto? ¿Qué tengo que poner aquí? Dame bitcoins. No funciona. Red principal, mainnet. Mis cuentas. Conectar monedero físico. Bueno, ya iremos aprendiendo todas estas cositas que significan. Pero en principio esto me ponía una extensión, ¿no? MetaMask. ¿Esto se puede quedar ahí o no? No conectado. Cero. Comprar. Depositar Ether. Para interactuar con la aplicación usando MetaMask necesitas tener Ether en tu monedero. Enviar. ¿Quién quiere? ¿Quién quiere dinero gratis? Vamos a seguir.
building the project. Instead of setting everything up manually, we're going to use a template that I've created called the DAP University Starter Kit. You can find this link down in the description below, but copy this URL and go to your terminal and say git clone, and then paste in the URL, all right? And then hit space and create your project name. In this case, I'm going to call it ETH swap. And now I'll enter into that newly created directory like this. I'll say cd ETH swap. And I'll install the project dependencies with npm like this. Say npm install. All right, once that's finished, you should see a success message here. Don't worry if you see a bunch of warnings here. It's not ideal, but they are just warnings for now. You'll know that it completed successfully if you have a message like this, all right? So really quickly, before we move on, I want to install one more dependency that's not included in the project yet. Okay, so if I go back to the application preview, you can see these things right here. These are called identicons, and we want to install a special library that helps us to create those. So -save identicon. Next special command on my computer to open the project in Sublime Text. Tests against them, deploy them to a blockchain, and also create our client-side website, all right? So I'm going to show you what's inside of here. The first place to take note is the truffle-config file. This is the main entry point for the application, where we the first place to take note is the truffle.
No queremos starter kits. No somos noobs. Trufa. Seguro que tiene un init o algo así, ¿no? Build, compile, config, db, debug, deploy, develop. Init. Inicializa un proyecto Ethereum. Esto es lo que queremos. Crear una carpeta. O me lo hará aquí. Hello Ethereum. No lo estáis viendo, perdonad. He escrito trufa init para inicializar un proyecto nuevo, porque el del vídeo me quería descargar un starter kit y le he dicho que no, y le he puesto nombre hello Ethereum. Vale, y me ha hecho esta carpeta de aquí, que por lo que veo es bastante similar a lo que explica el tío en el vídeo. Truffle config, test, migraciones, contratos. Ni idea. A ver qué nos sigue explicando.
Config file. This is the main entry point for the application, where we specify our connection to the blockchain. This shows the development network that connects to Ganache.
Vale.
This tells us which compiler we want to use to compile the smart contracts. And then also it shows us where the smart contracts live inside the project. So if you've used Truffle before, this may look a little new to you. That's because I've configured this project to automatically put the smart contracts in a different place than where they normally are in the project. That's because I want to access those smart contracts from the client-side application that we'll build in this tutorial. And you'll see that more at play here in a minute. So,
vale. Vale, esto es bastante diferente a lo que él nos enseña. Pero vamos a ver qué tenemos por aquí. Este es el archivo de configuración del trufa. Common settings, bla bla bla. Ni idea. FS. Esto ya es cosa de Node. Aquí exportamos algunas cosas. Networks.
I'll just show you. Put the smart
Exportaba solo networks.
contracts in a different
Networks development. Networks development. Vale, este host es el mismo, 127001. Vale, este es el localhost, ¿vale? El puerto él le ha puesto otro, pero nos da igual. Y en el network ID también, estrellita. En principio esto es lo que nos va a permitir conectar nuestro navegador a la blockchain esta del Ganache. Y luego lo otro que tenía es compilers. Advanced nada, provider. Compilers, este de aquí. Sol C. Y lo único que tenía descomentado es optimizer. Enable true, runs 200, vale. Esto lo tenemos igual. Versión, docker true. Usar a Docker. DB enabled false. Base de datos. Ok. Y él lo que decía también es que había metido la carpeta de los contratos y el build en otro sitio. Pero bueno, de momento lo vamos a dejar así. Networks, compilers. Y si eso ya lo cambiaremos más adelante si hace falta. Yo creo que él lo hace porque, o sea, por lo que ha dicho, va a hacer una aplicación de React y necesitas que dentro de la carpeta source esté todo, pero como nosotros si hacemos una aplicación web, no sé, no creo que la hagamos hoy, no nos dará tiempo, pero si la hacemos en algún otro día lo haremos con Next o con alguna otra, con otro framework de estos con los que trabajamos normalmente, y no hace falta tenerlo todo en una carpeta source. Está perfectamente esto así, tal y como está. Vale, vamos a seguir.
Place
Si tenéis preguntas o lo que sea, id poniéndolas por el chat, ¿eh? No hay problema.
than where they normally are in the project. That's because I want to access those. The smart contracts are inside application that we'll build in this tutorial. And you'll see that more at play here in a minute. So I'll just show you. The smart contracts are inside the source contracts directory. We can see this migration contract that's already here. This is a smart contract that comes with every Truffle project that basically just handles deploying other smart contracts to the blockchain. So don't worry.
Vamos a instalar la extensión esta de Solidity que nos ha aparecido automáticamente en el VS Code. A ver si eso nos pone los contratos estos bonitos. Vale, para los que no tengáis ni idea, un smart contract es un programa que se ejecuta en una blockchain. O al menos eso es lo que he entendido de leer un poco. De hecho, no sé, escuchando alguno de estos podcasts, no sé quién decía que realmente un smart contract no es más que un dumb program. Me hizo gracia, porque es verdad, es un programa tonto, porque ya veréis que tiene... A ver, pueden ser complicados, pero normalmente no es nada comparado con hacer redes neuronales. Entonces simplemente eso. Lo que pasa es que hay que escribirlos en un lenguaje de programación especial, al menos lo que serían los scripts o los programas para ejecutarlos en la blockchain de Ethereum necesitan estar escritos en un lenguaje de programación especial que se llama Solidity, ¿vale? Por eso este archivo se llama migrations.sol, ¿vale? La extensión sol esto es un script escrito en un lenguaje Solidity, igual que un archivo .py es un programa escrito en un lenguaje Python, pues lo mismo. Alex pregunta, llega un poco tarde, ¿qué objetivo tienes pensado para aprender blockchain? De momento, a ver si podemos hacer algún Hello World facilito para empezar a aprender estas cosas, ¿vale? Nos hemos descargado 3 o 4 programas que hemos visto de un tutorial, ¿vale? Uno se llama Ganache, que básicamente te pone una blockchain en tu ordenador para hacer pruebas. Y luego, habiendo ya instalado Node, ¿vale? El entorno para ejecutar programas en JavaScript, que ya hemos utilizado en muchísimos otros vídeos, pues hemos instalado una librería que se llama Truffle, y al hacer Truffle init hemos iniciado un proyecto, ¿vale? Le he puesto de nombre Hello Eth, por ponerle algo, ¿vale? Y estamos un poco investigando qué es lo que hay por aquí. Entonces, un poco el objetivo es pues aprender qué es la blockchain, en este caso, cómo ejecutar programas en la blockchain. Y si eso más adelante, pues yo qué sé, hacer una moneda propia, el Sensio Coin, o he visto también que se pueden hacer bots para comprar y vender tokens de forma automática. Pues todas estas cositas las podemos ir aprendiendo también. A ver qué sale. Lo que sí que está claro es que saber hacer esto, o sea, tener la habilidad de saber hacer programas en blockchain, creo que va a ser algo muy, muy importante en los próximos años. O sea que al menos que nos suene. Pongo un par de Sensiocoins para llevar. Hombre, ya he dicho, todos los que estéis aquí en este directo, cuando los Sensiocoins valgan millones, espero que seáis ricos, porque tendréis que comprarlas cuando las saquemos. O no sé si al principio se pueden regalar y todo, ¿no? Ni idea. A ver. Estábamos viendo el contract este por defecto que nos ha puesto el Truffle. Vale, aquí vemos algo llamado contract, que entiendo que será como una clase, ¿no? Tendrá la palabra esta especial contract para decir esto es un contrato. Pragma Solidity y números. Entiendo que esto le dirá de alguna forma, oye, esto es un programa escrito en el lenguaje Solidity y esto pues entiendo que tendrá algo que ver con versiones. El contrato que se llama Migrations, y aquí dentro de este contrato pues tenemos, siguiendo un poco lo que sería una programación orientada a objetos, que entiendo que es en lo que se ha inspirado este lenguaje de programación, pues estos serían como diferentes atributos de esta clase, ¿no? Y las diferentes funciones o métodos. Entonces algo que se llama address public owner, entiendo que esto será la dirección del dueño de este contrato, que espero ser yo, ¿no? Si yo desarrollo este contrato y lo pongo en la blockchain. Un número entero sin signo, también público, last completed migration. Esto se guardará pues quizá eso, ¿no? Cuando fue la última migración. Por lo que ha dicho, ¿no? El del tutorial, este es un contrato para desplegar nuevos contratos, ¿no? Así que lo que hace, tenemos aquí modifier restricted. Esto de modifier, por lo que he leído así un poco la documentación de este lenguaje de programación o algunos otros tutoriales que me he estado viendo, es como un middleware, ¿vale? Algo que cuando ejecutas una función, por ejemplo esta setCompleted, lo pones aquí, de forma que para ejecutar esta función primero se ejecuta esto y si esto no falla, entonces se ejecuta esto. ¿Vale? Es como si pusieseis aquí dentro un if, ¿no? If, si soy el owner, ejecuta esto. Pues lo mismo, pero en otra función, de forma que se puede reutilizar. Requiere que el message sender sea igual al owner. Set completed. Vale. Esto no lo quiero guardar. Vamos a seguir a ver qué nos dice.
Worry really too much about what's happening inside of here. Just know that this comes standard with Truffle projects, and you don't have to edit this code or really even understand it. Next, you can see a components directory. This is where all the application code for the client-side application will live. This is React.js code. So React organizes all of its code into these reusable components, which we'll talk more about when we get to the client-side portion of this tutorial. But I want to just make a note of that here. All right. And then next, we have a migrations directory. This is where we'll create migrations to put the smart contracts on the blockchain. We'll talk.
Vale, nosotros de momento no tenemos nada de aplicación frontend, ya lo meteremos más tarde, como decía antes. Pero ha dicho que en la carpeta migraciones, aquí se hacen las migraciones, que no sé lo que es, la verdad. Artifacts, require migrations. Y exporta una función que despliega estas migraciones a la blockchain, ¿no? Es lo que ha dicho. Ok.
Talk about that more when we get to that. And then finally, the package.json file. This is where we specify all the project-specific dependencies that we need in order to build the project. And also, while we're inside of here, we can change this name to, let's see, ETH swap.
Esto a mí no ha hecho, ¿no? Un package.json aquí. Eso es raro, ¿no? Debería haberlo hecho porque si no, ¿cómo sabe todo lo que tiene que instalar y todas las cosas? ¿No? Normalmente cuando haces el init de alguna aplicación en Node, te instala ya el package.json y todo eso. los docs. Traffic overview. Building. Smart contract application. Automatic. Installation. Creando un proyecto. Creating a project. To use most traffic commands, we'll use meta coin box, which creates a token. Compiling. Truffle compile, build artifacts, dependencies, importing contracts, running migrations, Truffle migrate, Truffle with MetaMask. Esto es lo que nos hemos instalado antes. Vamos a seguir hasta que nos encontremos algún problema.
And we'll just say an instant ERC20 cryptocurrency exchange added manually via the command line right here. So next, let's go ahead and boot up the web server for the project just to make sure that it was installed properly. I'm going to open up a new terminal tab to do this. All right, and I'm going to say npm run start, and that should automatically start the web server and open up the website, the client-side website, in a new browser tab. Boom, there we go. So this is what was installed. This was the DAP University starter kit. So you can see this already looks really nice. It has some styling already and everything. Yeah. So whenever we create, for now, we'll come back to this whenever we're out. We'll use, our primary of the application. But I'm just going to leave the web server here running in a separate tab. And don't forget about it. Whenever we come back, I'll remind you when we build that part of the application. But next, what I'm going to do is go ahead and start developing the smart contracts. And we'll use, our primary terminal tab for this, and then leave the web server running in the background. Okay. I'll create a new file for the smart contract like this. I'll say touch. Let's see here, source contracts, and we'll say capital E, ETH, capital S, swap.sol. All right. And you can do this from your text editor if you want to. You don't have to do it from the command line. But if you look here, go to source contracts, you'll see this ETH swap file that was created. Inside of here is where we're going to write all the Solidity source code for the smart contract. Okay. So we can start off by doing this. We can say pragma Solidity. I'll use a caret. And say version 0.5.0. All right. So what this does is it declares the Solidity programming language version that we want to use. So the next thing that we do is create the smart contract like this. We say contract ETH swap. All right, then we use some curly braces. And inside these curly braces is where we'll write all of the code for the smart contract. You'll say that it belongs to this contract named ETH swap. All right. So the first thing that I want to do is just create a really simple test or a demonstration to see how it works. And what we're going to do is create a name for the smart contract. And we'll do this with a variable like this. All right, so we'll say name equals ETH swap instant exchange. All right, and now, this is a string, which basically just means it's a human readable, set of characters like this inside of these quotation marks. And we must follow each line with a semicolon like this, okay? And then finally, we must tell Solidity what type this is, all right? Because it's a statically typed language. So we say string name, okay? So it can't be a number later or something like that. It always has to be a string. And then finally, what we want to do is read this variable value outside of the smart contract. So we must call it public, all right? So string public name equals, the string ETH swap instant exchange followed by a semicolon. So this actually creates a lot of functionality for us in one simple line of code, which we'll see here in a minute. Because we declare this public, Solidity is going to give us a function that we can call on the smart contract called name, which is going to return this value, okay? And, there are different visibilities and functions, which we'll see later in Solidity in this tutorial. But this basically just means that, if we didn't have this, we wouldn't be able to read that name value later outside the smart contract. But because we do, we'll be able to read this like in the console, which I'm going to show you here right now. All right, so let's just see if we can put this smart contract on the blockchain and interact with it in the console. Vale,
entonces creamos un nuevo contrato y ¿cómo le llamamos? ETH swap le ha llamado él. Y aquí le ha puesto el pragma Solidity. .050. Ok. Creamos un contract con el mismo nombre. Y aquí una variable de tipo string public name eth swap sensio exchange. Esto no le gusta. Expected punto y coma. Vale, pues aquí hay que poner puntos y comas también. Source file requires different compile version. Current is 083. Before publishing, consider adding a comment. Quiere una licencia. Pues esta misma. Y si le ponemos esto igual que en el otro, funcionará. Espero que sí. Vale, pues hemos creado contrato, le hemos llamado de nombre ethSwap. Y dentro de este contrato hemos definido una variable name de tipo string, pública para que se pueda acceder desde fuera de este contrato. Y el contenido de esta variable string pues es ethSwap, le he llamado sensio exchange. Vale, vamos a hacer una aplicación, según tengo entendido, donde vamos a poder cambiar tokens Ethereum por tokens de otra criptomoneda. Sensio coins, para ser más exactos.
To see that the project's set up properly. So what we'll do is go to the migrations directory, all right? And you see this initial migrations file. We're going to create a new file here. And we'll call it all right? We'll call it deploy contracts.js, all right? So let me tell you what these migration files do. Essentially, they just take a contract, a smart contract, and put them on the blockchain. So that's what this code does. And Truffle basically has these things called artifacts, which are, kind of JavaScript versions of the smart contracts with JSON. And, you're able to assign them to variables like this in JavaScript, and Truffle's deployer knows how to put them on the blockchain like this. All right. So essentially, we're just going to follow this pattern and copy and paste this. You don't have to reinvent the wheel here. So I'm just going to do that, put it in the deploy contracts directory, and say eth swap, right? So that's just going to it's going to fetch the eth swap contract we just created and put it on the blockchain. So lastly, I'll say that migration files inside of Truffle are a lot like, migrations that you might have seen in another context if you're a developer already. So maybe you've seen a migration to change a database like with SQL or MongoDB, something like that, where you're essentially creating new tables or something like that, maybe adding columns. It's the same thing in Truffle. So in those contexts, you're migrating the state of a database from one state to another. You're adding new tables. In this case, you're also changing the blockchain state from one state to another. And also, you're technically migrating smart contracts from your development environment to a blockchain. Okay, so that's a few different ways you can think about it. Before you run the migrations, make sure that you have Ganache running, right? So don't forget, this is your development blockchain. So find wherever you installed it and opened it and make sure that it's running. You might see a quick start button or something like that. Go ahead and click that. And when you see a page like this with the accounts and their balances, you'll know that Ganache is ready to go and that you're connected to it with the right port 7545, right here inside your Truffle project. Now that that's finished,
vale. Ha dicho que hay que conectar el Ganache a la network de desarrollo. Y nuestra network de desarrollo está en el puerto 8545. Entonces, si yo vengo al Ganache, ¿cómo lo paro esto? Save, switch, network. Ah, no, esto es el network ID, perdón. El puerto es 7545. Vale, pues simplemente lo voy a cambiar en el proyecto. ¿Vale? Este es el puerto al cual se conecta el Ganache, ¿vale? Entonces simplemente vamos a levantar nuestra blockchain de desarrollo en este puerto. Pero antes teníamos que crear una nueva migration. 2. Le he llamado deploy, ¿no? Deploy migration, si no me equivoco. Deploy contracts. aquí ha cambiado todo el migrations por ETH swap, que es como le hemos llamado a nuestro contrato. Grisel, soy tu fan. Gracias. Yo soy tu fan también.
You're connected to it with the right port 7545, right here, inside your truffle project. Now that that's finished, we can migrate the smart contracts like this and put them on the blockchain. So we just go to the terminal and say truffle migrate, all right? And there you go. You can see that it first compiled the smart contracts, it started the migration process, the initial migration contract was deployed, and then finally our ETH swap contract was also deployed. Okay.
Vale. Trufa. ¿Deploy? ¿O migrate? ¿Qué ha dicho? Migrate. Ahora es cuando todo peta, obviamente. Se veía venir, gente. Estábamos llegando ya demasiado lejos. No he encontrado el configuration file. Pues está aquí. Truffle no funciona. Ah, vale. Que no me he metido en la carpeta. Creo que sí que somos noobs, ¿eh? Y tendríamos que haber usado el starter kit. Mígrame. Funciona, por favor. Oh, compilando contratos. Sí. ¿Vale? ¿No hay errores? Compilando contratos. Compilando lead swap. Migrations. Successfully. Starting migrations. Network ID 5777. Deploying gas price 20 guay. Total cost 0,0. ¿Cuesta dinero desplegar smart contracts? Pregunta muy noob. ¿Cuesta dinero o en este caso cuesta Ether? Parece que sí, ¿no? Voy a arruinar.
All right. And there you go. You can see that it first compiled the smart contracts, it started the migration process, the initial migration contract was deployed, and then finally our ETH swap contract was also deployed. Okay. The next thing we want to do is interact with the smart contract in the development console like this. We just open it by saying truffle console. All right, this is going to give us a JavaScript environment where we can, write JavaScript commands that will interact with the blockchain and also interact with the smart contract that we just created. So I'm going to fetch the smart contract like this. All right, we say contract equals await.
Mira. Antes de seguir, en la primera cuenta del ganache ha bajado en la primera dirección. Entiendo que esta es la dirección que ha utilizado para desplegar este contrato, y el hecho de desplegar un contrato en esta blockchain cuesta Ethers, que entiendo que son estos 0,007 que nos decía el Truffle.
Wait, ETH swap got deployed. All right. And sometimes people get confused because they say undefined here, but we can simply access the contract like this. We just retype the contract variable, contract. All right, boom, there we go. And we can fetch the contract address like this. We say contract address. All right, and then we can fetch the contract name like this. We just say name equals await contract.name, followed by two open and close parentheses, right? So no parentheses here, but parentheses here. And we say name, Boom, there we go. ETH swap instant exchange. Perfect. So really quickly, I'll explain a few things here. Boom, there we go. Equals a whale. Kind of confused because I say undefined.
Vale. Truffle tiene una consola. Vale, esto es como si escribís Python en vuestra consola, pues os abrirá el interpretador de Python, o si escribís Node os abre el interpretador de JavaScript, pues lo mismo. Truffle Console nos abre una consola con la que podemos interactuar con los contratos que acabamos de desplegar, o el contrato. Vale, entonces, si hacemos, como he dicho, contract igual await, ¿vale? Este await normalmente se utiliza cuando una función es asíncrona para esperar a que devuelva el resultado, porque si no, pasaría a la siguiente línea de código, o en este caso no haría nada, hasta que no devolviese una respuesta. ETH swap, el nombre del contrato. Deployed. Contract address. Vale, esto no coincide con la address del ganache. Así que ahora estoy un poco despistado. Quizá no, es que no es la misma. Quizá la address esta del ganache es mi dirección y esta dirección es la dirección del contrato y son cosas diferentes en la blockchain. Podría ser, ¿no? Bueno, y al final lo que nos interesaba, que era acceder a esta variable. Esto es una función.
Find here.
¿Cómo lo hacía para sacarla? Llamándola, ¿no? Await contract name y substance exchange, ¿vale? O sea, ahora mismo este programa está metido en una blockchain, aunque de momento es de prueba, que solo está corriendo en mi ordenador. Será como simulando esta blockchain, ¿vale? Pero ahí dentro hay un programa y ese programa tiene una variable que se llama name, que hemos sacado a través de esta función getter, ¿vale? Esto nos lo ha dado automáticamente, esto es lo que ha dicho en el tutorial, ¿vale? Al poner que esta variable es pública, automáticamente podemos acceder a esta variable simplemente con el mismo nombre, pero llamándolo como una función, ¿vale? Esto es lo que normalmente se llama un getter, para hacer un get de un valor. Ok. Seguimos.
And we say name. Boom, there we go. ETH swap instant exchange. Perfect. So really quickly, I'll explain a few things here. First is the contract address. So if you open Ganache, you'll see that you have accounts already here on the blockchain, and these have addresses. These essentially represent the users on the blockchain. The addresses are like a username.
Vale, ahora va a explicar la duda que tenía.
And the private key is sort of like a password, right? So the same is true for smart contracts. They also have addresses. So essentially, this just tells it the location, or kind of like the username of the smart contract on the blockchain.
Vale, pues sí. O sea, nosotros como usuarios tenemos direcciones en la blockchain, que es lo que nos da el Ganache aquí, estas 10 direcciones de prueba, pero nuestros contratos en la blockchain también tendrán sus propias direcciones, para saber, imagino, dónde están, ¿no? Y cómo encontrarlos.
So yeah, that's what this is right here. The other thing I want to explain is this await keyword. All right, so whenever you're interacting with the blockchain, a lot of times, especially in JavaScript, you're doing asynchronous interactions, which essentially means that the function calls a lot of times don't actually return the value that you're asking for. So for example, when you say name, if I just did like name equals contract.name, this is a way for JavaScript to say, oh, okay, asynchronous function tutorial. Now we've created a basic file for our ETH swap smart contract. Okay, this is going to be the contract where we create buying and selling tokens in this tutorial, and we'll continue building out this throughout the remainder of this series. Okay, so the next thing we want to do is create a second smart contract for the token. All right, so if you go back and revisit the diagram
se viene SensioCoin
that I talked about earlier, we have our website that talks to the blockchain, and then the first smart contract is the ETH swap smart contract. That's what we just created here. Right, and the second smart contract is going to be the token that we buy and sell with Ether, right? The native cryptocurrency of the Ethereum blockchain, right? And that's the smart contract that we want to create right now. So I'm going to go ahead and create a new file here. So I'm just going to reveal this here. Contracts, ETH swap, right? We'll create a new file. And here we'll say DApp token, or we'll say token.sol. capital T OKEN.sol. This will be called DApp token. I'll show you how to do that here in a minute. But this is going to be the file where we create the second smart contract for the cryptocurrency that we're going to buy and sell. So let me explain how this works. Ethereum allows you to create your own cryptocurrency without creating your own blockchain, which is really powerful. It basically means you can write a smart contract like this to govern a cryptocurrency. All right?
Vale, importante. Al inicio de los tiempos de las blockchains, si tú querías tener tu moneda, por lo que entiendo que está explicando ahora, tenías que hacerte también tu blockchain. Por eso Bitcoin es la blockchain y la moneda, ¿vale? La diferencia es que la B es mayúscula o minúscula, no sé cuál es cuál. Y en Ethereum lo mismo, o sea, tienes la moneda, el Ether, y tienes la blockchain, que es Ethereum, ¿vale? Una sería como la infraestructura y la otra sería esta criptomoneda, ¿no? Entonces, una de las ventajas que tiene Ethereum y el hecho de poder escribir estos smart contracts, que al final son programas que se ejecutan en la blockchain, es que nosotros nos podemos hacer nuestros propios tokens, nuestras propias criptomonedas, sin necesidad de tener que montar la infraestructura, ¿vale? Sin necesidad de tener que montarnos una blockchain, ¿vale? Entonces, que lo sepáis, y yo también lo acabo de aprender. Hay criptomonedas que tienen su propia blockchain y otras que están hechas encima de otra blockchain. De hecho, creo que la mayoría están hechas por encima de Ethereum. Si me equivoco y alguien tiene más idea de esto en el chat, por favor, que me corrija. Al final aquí estamos para aprender.
Something called an ERC20 token. So you might have heard of that, right? It's pretty popular. If you go to a website like coinmarketcap.com, you can see a list of ERC20 tokens. I mean, this is all the cryptocurrencies, but on this list, you'll see, let's see here, tokens like Maker is an ERC20 token. If you look at like 0x, it's an ERC20 token. You can find a complete list of these, but just note that, you can just go to the homepage and see plenty of them there, right? And if you look at any of these ERC20 tokens, you'll just notice that they all have a lot in common, all right? They all work the same way. And actually, if you go to their smart contracts, you can look at the code, and they all, like I said, they work the same way. Basically, they have like the same functions. They have a transfer function, they have an approve function, all right, a balance of, and that's because Ethereum tokens have to follow a standard, all right, called ERC20. So ERC20 is a standard for Ethereum tokens that just governs how they all work. It specifies a set of functions and behavior that the tokens must implement in order to be supported on, cryptocurrency exchanges, to be held in wallets, to be sent around. It basically just creates, a set of rules that they must abide by, so they're not, constantly trying to reinvent the wheel with how they handle cryptocurrencies, all right? So you can read through the entire ERC20 spec here if you wanted to, but essentially I'm going to call out a few things. Token must have like a name, symbol, and some decimals, okay? So I'm going to call out a few things here. So for example, the token must have a transfer function. This is what allows it to send tokens. And it also must have, let's see here, an approve function, and also like a balance of function to get the current balance of whoever holds the token, all right? So it also supports things like name, symbol, and decimals, which we'll see here in a minute. So particularly in this tutorial, we're going to focus on the balance of function and also the transfer function. This is going to show us how many DApp tokens we hold, like this, right? You'll see the balance here. And then also the transfer function, which is going to be used whenever we sell the tokens in the ETH swap contract. So just notice that ERC20 is a standard. Pretty much all ERC20 tokens have to implement these types of functions. And because of this, I don't want to reinvent the wheel and code out a basic ERC20 token step by step, right? So we're going to use this ERC20 token here. I'll put a link down to this. Sorry, I'll put a link for this down in the description below. And we're just going to copy and paste this code for the ERC20 token inside of our project, all right? So if you want to learn to build this ERC20 token step by step, you can check out my full length tutorial, Code Your Own Cryptocurrency on Ethereum, okay? And this will show you how to build it step by step, right? This is like an 8-hour tutorial series. But I don't want to reinvent that. You can follow that tutorial if you want to. And for the sake of getting started in this, we're just going to copy and paste this and put it in our project, okay? So don't worry, we're going to get plenty of practice coding Solidity smart contracts when we build the ETH swap exchange. But I want to use this to save some time, right? So we'll go to our project and go to token.
Vale, lo habéis pillado. La cosa es que los tokens estos, para que funcionen encima de Ethereum, tienen que seguir un estándar, ¿vale? Con unas funciones particulares. Entonces eso es lo que hay que hacer, coger esas funciones y meterlas en tu token. Vale, este es el link que ha puesto aquí. Sí, ¿no? Aquí explica pues todas las funciones que hay. Pues tienes que tener un nombre, tiene que poder transferirse, en fin. Todas estas funciones son necesarias para que este token sea válido en la blockchain de Ethereum y se pueda intercambiar en los diferentes exchanges como el que nosotros vamos a hacer. Pero ha dicho que pondría otro link, ¿no? A otro sitio, pero no lo ha puesto.
We're just going to copy and paste this and put it in our project, okay? So don't worry.
DApp token.sol github.com. JWM Cubin. Ha puesto el link. Aquí nos sale una lista con los gist esos. ¿Alguien sabe cómo encontrar los snippets o los gist esos? GitHub gist. No, no quiero crear. No está. Lo ha borrado. Transfer approval, transfer approve, transfer from, transfer approval, transfer.
We're going to get plenty of practice coding.
Approve, transfer. Va, es el mismo. O si no, ya lo cambiaremos. Token. Perdón. Vale, aquí en el Visual Studio Code hacemos el token.sol, ¿vale? Este va a ser ahora el contrato que va a tener nuestro token. Y aquí voy a copiar el snippet este, que tiene todas las funciones que hacen falta para que este token sea válido. Vale, aquí las veis. Transfer, approval, constructor, transfer, approve, transfer from. Bueno, ahora las iremos viendo, yo imagino, poquito a poco. Nos las irá explicando nuestro amigo, ¿cómo se llama? Dap University. Voy a hacer un café. ¿Alguien quiere algo?
Solidity smart contracts and we build the ETH swap exchange. But I want to use this to save some time, right? So we'll go to our project and go to token.sol and paste this in here. All right, you can see all of the features of the ERC20 tokens here, like the transfer function. You have balance of here. All right, and also the approve function. Right. And again, you don't have to know how all this code works. Basically, just know this transfer function is what sends tokens from someone to another person. The balance of function tells you how many tokens you have, and then also the approve function, lets somebody else, spend your tokens. So we'll see these in action. And if you want to learn more about how this works, go follow that other tutorial. All right, now let's finalize our setup and put this token on the blockchain too. So let's go back to the deploy contracts file inside our migrations directory. And what we're going to do is put the token on the blockchain as well. So I'm just going to copy this, and paste it. All right. And we'll change this to token. I'll put it first. And then just like this, we'll say a token as well. All right, and then I'm going to say deploy token. All right, and then deploy ETH swap. Okay, so now let's put this on the blockchain as well. So I'm going to...
Vale. A ver, lo primero que vamos a hacer es cambiarle el nombre y le vamos a llamar SensioCoin. Y símbolo ¿qué símbolo le pongo? Necesito vuestra ayuda. SEC SensioCoin Senc, ¿mola o qué? ¿Qué vota la gente? SEC, SNC, SENC. Bueno, lo dejamos en Senc, pues. Vale, estos son todo variables públicas, como ya hemos visto antes. Nombre del símbolo, el estándar. Esto del total supply, pues supongo de cuántas SensioCoins habrá. Un número entero sin signo, por lo tanto no puede haber menos SensioCoins, tienen que ser positivas. Y como máximo habrá... ¿Cuántos son? 256. Dos elevado a 256, ¿no? Función transfer. Bueno, función event. No sé exactamente qué significa esto. Esto tendrá una dirección desde la que está enviando las SensioCoins a una dirección a las que está enviando y cuánto queremos enviar, entiendo. Eso será una transferencia. Luego tenemos algo que se llama approval, que imagino que es para aprobar una transferencia. Esto es una dirección del que posee las SensioCoins, owner, spender. Similar, ¿no? Al transfer. Un mapping de addresses balance of. A esto entiendo que dirá pues quién tiene cada una de las monedas de los SensioCoins. Vale, si al principio yo tendré todas las SensioCoins, pues esto será pues como una lista, ¿no? Un array, un map, ¿vale? Un dict de Python, un mapa, clave valor, la clave será la dirección y el valor pues será los SensioCoins, ¿no? Pues habrá una dirección que sea la mía con todos los SensioCoins. Cuando yo le pase algún SensioCoin a alguien, pues esta variable, ¿no? Tendrá será como una lista con 2 entradas, yo y la otra persona que tenga Sensio Coins, y cada uno pues cuántas Sensio Coins tienen. Allowance, otro mapping de direcciones a otro mapping de direcciones. Esto ya sí que me pierdo un poco. Allowance. Constructor, ¿vale? Esto es en programación bastante habitual, ¿no? El constructor es la función que se llama para inicializar, en este caso, este contrato, este token, ¿vale? Y aquí, por lo que veo, le pasaremos un valor inicial de Sensio Coins, ¿vale? Pues diremos, queremos crear esta criptomoneda con tantas criptomonedas, ¿no? Pues 1 millón o 2 millones de Sensio Coins. Pues esto es lo que se encargará de crear esas Sensio Coins, ¿vale? Veis que aquí en la variable está el balance of, que efectivamente parece como un array o como un map. Dirá, vale, pues el message sender, esto entiendo que será la dirección de la dirección de la persona que despliegue este contrato. Por lo tanto, yo voy a tener todas las Sensio Coins al principio, cuando se cree este contrato, cuando se cree esta moneda. Y el total supply, que era esto de aquí, pues es igual al initial supply. Vale, esto queda bastante claro. Repito, cuando creemos este contrato, le diremos cuántas Sensio Coins queremos, me las pondrá todas a mí, o la persona en este caso que despliegue este contrato, y dirá, vale, pues hay tantas Sensio Coins como le digamos aquí, pues 1 millón, por ejemplo. Vale, y estas son las funciones para transferir. Función transfiere desde esta cuenta tantos valores y devuelve una variable booleana de si esto ha funcionado o no. Estaremos requiriendo que la persona que está llamando a esto de message sender, no sé si es la persona que llama a esta función, entiendo que sí, ¿no? Que puede ser yo o cualquiera otra. Vale, comprobaremos que tengamos al menos lo que queremos transferir, ¿vale? Este valor tiene que ser mayor o igual a lo que queremos transferir. Cogeremos todas mis monedas y les restaremos las que transfiramos, y a aquella persona a la que le estemos transfiriendo, pues se las sumaremos en su balance. Y entonces emitimos esta transferencia desde la persona que llama esta función a la persona a la cual le está enviando las monedas y todas las monedas que está enviando, ¿vale? Y este transfer es un evento que tenemos aquí descrito. Y si no pasa nada raro, pues devolverá true, ¿vale? Queda bastante claro también. Approve. Spender value. ¿Esto qué será? ¿Para dar permisos a alguien de que se gaste mis monedas? Porque este allowance será un mapa de mapas. Es como yo permito que tú te gastes estas monedas. ¿En mi nombre? Entiendo que sí. O sea, no es que yo te haga a ti una transferencia y tú luego hagas con eso lo que quieras. No, yo tengo tanto y te permito a ti que transfieras esas monedas en mi nombre. Transfer from. From to. Transfieres tu valor. ¿Vale? Esta función parece que sirve para transferir Sensio Coins o el token que sea de una cuenta a otra. Pero si esta función transfer directamente cogía mis monedas y se las enviaba a quien yo decía, ¿vale? Para que esto funcione, la persona que llama a esta función tiene que estar dentro de las permitidas en la cuenta desde la cual quiere transferir. Y entonces se vuelve a hacer estos balances y el allowance. Sí, parece que la diferencia es esa, que esta función transfer tú la llamas para transferir directamente de tus monedas a otra persona, y esta función se va a llamar por cualquiera para hacer transferencias entre dos cuentas, y para que funcione obviamente ese cualquiera tiene que estar dentro de la lista de direcciones permitidas. Vale. Si tenéis preguntas, ya digo, podéis hacerlas por el chat y paramos y las miramos. Esto parece que da un error, un warning. La visibilidad del constructor se ignora. Si quieres que este contrato no sea desplegable, hazlo abstracto. De momento lo dejamos así.
Exit the truffle console like this.
Ah, y me olvidaba ahora que tenemos también que añadirlo a el proceso este de migraciones. El token. Vale. Y creo que ya directamente podíamos desplegarlo, ¿no? Compilando contratos, ha compilado el token sol. Entiendo que como los otros no los hemos cambiado, no ha compilado nada. Y si ahora entramos en la consola,
say exit with a dot in front of it. All right, that. Well, smart contract code is immutable. All right, it cannot change. That's the whole point. Whenever you write the smart contract code and you put it into the blockchain, you can't update it like you would a normal application. So the only thing you can really do is deploy a new copy of it to the blockchain, and that's exactly what this reset operation does. So if I say truffle migrate dash dash reset, hit enter, it's going to put a new copy of.
Gracias, Cristian, por tu mensaje. De verdad que me sirve mucho.
The ETH swap exchange on the Ganache blockchain, and it's also going to put the token, right? So you can see that.
Me ha dicho que le haga un reset, además. Oh, ha petado. Cuando ha intentado desplegar token me ha dicho invalid number of parameters for undefined. Got 0, expected 1. Vamos a ver si a él le funciona.
That here, right? So see your token and then ETH swap. So now I'm going to aim and it's a new copy of it to the blockchain, and that's exactly what this reset operation does. So if I say truffle migrate dash dash reset, hit enter, it's going to put a new copy of the ETH swap exchange on the Ganache blockchain, and it's also going to put the token, right? So you can see that here, right? So see your token and then ETH swap. So now I'm going to enter the truffle console.
Vale, sí que le ha funcionado. Vamos a hacer la prueba de ejecutar otra vez lo que no ha funcionado, a ver si por lo que sea aparece la virgen, pero no. Invalid number of parameters. Vamos a cambiar la versión. Aquí ya empieza un poco prueba y error. Porque como no tengo ni idea de esto, esto me está diciendo que no. gusta, ¿eh? No. Oh, vamos a copiar esto. A ver qué nos dice Google. Invalid number of parameters. Got 1 expected 0. A nosotros nos dice got 0 expected 1. Ah, vale, claro. O sea, nosotros cuando desplegamos esto le tenemos que pasar el número de Sensio Coins que necesita. Espera que le digamos al desplegar cuántas Sensio Coins queremos, pero no se las estamos dando. ¿Y esto
Via the
cómo lo ha
swap
hecho?
is reset. Then and just like this, we'll say a token as well. All right, and then I'm going to say ETH swap. Okay, so now let's put this on the blockchain as well. So I'm going to exit the truffle console like this, say exit, function. So we'll see these in action. This token on the, if you
Amigo, él lo ha puesto directamente aquí. Pues vamos a ponerlo también. Ay, no lo estabais viendo. ¿O sí? Sí lo estabais viendo, ¿no? 1 millón de tokens. Esto me lo cargo. Y además tiene esto que dice Wint8 public decimals 18. Y aquí tiene 1 millón de tokens. ¿Cuántos ceros son? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 1 million Sensio Coins. Habrá suficientes, ¿no? Para todos. Tiene el transfer, tiene el approval, balance allowance, vale, claro, y ahora en el constructor no le pasamos nada y el total supply se lo mete a quien lo despliegue. Vale, y las otras funciones
So let's go back.
en principio son iguales.
Editable. All right, it cannot change. That's the
Vale, ahora sí. Vale, en el ganache de hecho veo que me ha restado más ethers de mi cuenta. Lo voy a poner aquí también. Vale, veis que ahora están 99.95. Vale, pues ahora en teoría hay 1 millón de Sensio Coins en algún sitio, ¿no?
the whole point. Whenever you write the smart contract code and you put it in the blockchain, you have the ETH swap exchange. Oh, sorry. Capital T. Await. Here, copy paste this. All right, say balance your string. All right, boom, there we go. So what we can see is
Vale, si volvemos a abrir la consola para interactuar ahora con nuestra blockchain. Token igual await token deployed SensioCoin. Vale, nuestro contrato
await
está
and the
en el,
first account second token balance of,
en la
and
blockchain.
then I'm going to pass in the first account.
Vale, si hacemos token balance of, vale, si os acordáis, el balance of es esta lista con toda la gente que tiene SensioCoins y la cantidad. Entonces aquí ahora hay que poner una dirección. ¿Vale? ¿Quién tiene las SensioCoins? ¿Vale? Y esta es la dirección que nos da este ganache. BN negative. Estoy poniendo algo mal.
Account second balance. All right, say balance your string. And
Await. En teoría me ha puesto todas a mí.
balance this. And balance. All right, say balance your string. All right, boom, there we go.
Vale. Tu string. Ahí están los SensioCoins. Tenemos 1 millón de SensioCoins en la blockchain. ¿Quién los quiere? De momento están en mi blockchain de prueba en mi ordenador. Ahora en algún momento tendremos que aprender a ponerlos en la blockchain de verdad para que los podáis conseguir y haceros ricos.
So what we can see here is that the first account inside Ganache has all of the tokens, right? And I'll show you why that is. So inside of the token file, you can see this constructor function. This is a function that gets run whenever the contract is put on the blockchain. And basically what we do, we take all the tokens and we assign them to the user that deployed the smart contract, okay? And in this case, that's the first account inside of Ganache. So you'll understand this more when we start explaining how smart contracts work and we code the other one out, all right? Don't worry if this is confusing yet, but essentially know that we took 1 million tokens, that's how many this is, and we assigned them to this account whenever we deployed the smart contract to the blockchain, okay? So that's, what we illustrated here. But that's actually not right, okay? We don't necessarily want the user to have all the tokens. We want the ETH swap exchange to have all the tokens because we're going to buy them. And we want the ETH swap contract to possess them so that we can buy them from that actual smart contract, okay? So what we want to do is transfer all the tokens from this account to the ETH swap exchange. And we can do that inside our migration file like this, okay? So basically, we'll just say, we'll fetch the token contract like this, const token equals await token deployed, just like we did in the console. All right, we'll do the same thing for ETH swap. So ETH swap, and then ETH swap. Okay, so now we have a copy of the token and a copy of the ETH swap contract, and we'll say transfer all tokens to ETH swap. Say 1 million, and we'll do await token transfer ETH swap address. And then we'll say, we'll just go to the token, copy the total supply, put it in here. And we'll say, yeah, there we go. That's all we need to do. So if you look at the transfer function, it just takes two arguments, the address that you're sending it to. In this case, it's going to be the ETH swap smart contract, and then the value, which is the total number of tokens that you want to send. In this case, we just paste it in the total supply, which means we want to transfer all the tokens to the ETH swap smart contract. Okay. And just note that inside of the Truffle project, the account that's performing all these actions is assumed to be the deployer or the first account inside Ganache like this. Okay. So you can also see that the Ether balance has gone down inside this account. That's because the deployer has paid the gas fees to put the smart contract on the network. Okay. So that basically means that anytime you do something on the Ethereum network, you create a new transaction, you must pay for it with gas, and that gas has been debited from this first account here. Okay. So now we can open the Truffle console again. Actually, sorry, let's migrate it. Say Truffle migrate -- reset. This will put new smart contracts on the blockchain. Okay, let's make our changes. Oh, looks like we had a problem here. Let's see here. Await is only valid inside of an async function. All right, so let's change that. We have to put the async keyword here. So we'll try that again. All right. Dot deployed. Dot deployed. All right, and say token, that all of the tokens are assigned to eSwap. Okay, all right, bye. This was my fault. So we have to do, if we're gonna use an order, is say await. I forgot about this, sorry everybody. All right, so await deployer.deploy token, await token. All right, so let's try that again. Say debug problems that you're copy and paste this. Let's just do this. And then we'll say balance. All right, there we go, boom. All the tokens have been transferred to the ETH swap contract and they're ready to be purchased. All right. So congratulations. You've come a really long way in this video so far. What we're going to do next is actually program the ETH swap smart contract so that we can start purchasing tokens from it now that they're all inside of the smart contract. But we're going to continue.
Perdón, se me había olvidado desmutearme el micrófono. Gracias, Paco, por avisar, que es lo último que he dicho y no se ha oído. Básicamente lo que tenemos que hacer es coger el contrato que genera estas criptomonedas, estos Sensio Coins, todos los tokens, ¿vale? Este de aquí, como hemos visto, al generarlos los tiene asignados a su cuenta, y lo que queremos hacer es cogerlos y enviárselos al otro contrato, que es el que se va a encargar de transferir estas cuentas entre diferentes, o sea, transferir estos tokens entre las diferentes cuentas, donde tú vas a ir, vas a decir, pues quiero 10 Sensio Coins, pues este contrato es el que se encarga de transferirlos. Lo que no me acaba de cuadrar es si todos los tokens los tiene este contrato y yo he desplegado ese exchange, ¿tengo yo esos tokens? Yo creo que sí, ¿no? Y otra cosa que no me gusta del todo es hardcodear aquí el total de tokens. No sé si se puede sacar de alguna forma. liado. ¿Se ve? ¿Se oye? Espero que sí. Vale, volvemos a ejecutar estas migraciones. Y aquí tenemos un error. Total supply no es una función. Probablemente porque no es pública. No, sí que es pública. Lo he escrito mal. Vale, ahora funciona. Y si abrimos la consola, antes teníamos todos los tokens en el smart contract llamado token. Esto no se acuerda, ¿no?, de lo que he ejecutado antes. ¿Cómo lo habíamos hecho? Await, token, balance of, o string, si no me equivoco. Vale, esta es la cuenta que antes teníamos aquí todos los tokens, ¿veis? Y ahora pone 0. Porque en teoría todos los tokens ahora los tiene el otro smart contract, que es el que se va a encargar de vender estas criptomonedas. Await, swap. Vale, este es el exchange donde vais a poder comprar mis Sensio Coins. Y ahora sí, este smart contract no tiene función balance of. ¿Cómo puedo saber el balance de otra cuenta? Hemos hecho un transfer.
What we're going to do next is, all right, there we go. Boom. I just swapped their token. All right. We did it in the last. The other thing is it's really that hard to do faster. Balance the address and balance.
Vale. Aquí hay que poner ahora la dirección del exchange. Perdonad, ahora. Vale, llamando a la función del balance of que está definida en el contrato este del token, pero con la dirección del swap, que no es la dirección, no es igual a la dirección que ha desplegado ese contrato. Vale, eso ya lo hemos visto antes. Vale, cada contrato tiene su dirección en la blockchain y cada usuario tiene su otra dirección. Ok. Venga, Seguimos.
to string. All right, there we go. Boom. All the tokens have been transferred to the ETH swap contract. They're all inside of the smart. So a lot of people. So let's start building it. But we're going to continue here, focusing on this smart contract and building it out. So specifically, we're going to create the buy tokens functionality. Okay, we're going to allow people to purchase their tokens with Ether. Right, they'll be able to go here, enter their Ethereum amount, and then receive a certain amount of tokens. So we're going to focus on the smart contract part of this, not the interface just yet, just the smart contracts. So let's talk about how we're going to do that. All right. So one way of doing this would be to just create the functionality and then go to the Truffle console and keep testing it out like we did in the last video, but that's really slow and inefficient. So what we want to do instead is write tests that make sure that the smart contract works the way we want to. Right. So there's several reasons for this. Tests, essentially, they do just that. They make sure that the code that you write works without having to interact with it, on a website or something like that, or in the console. And you can always keep running them, and it just saves you a lot of time. And the other thing is, it's really important to test smart contracts before you put them on a blockchain and ensure that they work. It's almost more important when you're developing blockchain applications and other types of applications because smart contracts can't really be changed, and you want to make sure that they work before you put them on a blockchain. And the testing phase where you write automated tests is critical for that development process. All right. So Truffle lets us write tests like this. We can basically just create a new directory. Right inside of here, we can say makedir, say mkdir test. All right. So you can see a new folder was created here. And this is where we'll create a new file. We'll say touch, we'll say test, and we'll say ethswap.test.js. Okay. And then you'll see that a new file was created here. All right. So this is the file where we'll write.
Vamos a hacer test. Ethswap test JS.
All the tests, and we're going to do it in JavaScript. So yeah, that's how Truffle works. Essentially, it gives us a way to write tests for Solidity smart contracts in JavaScript. So yeah, it's two different programming languages here. This is Solidity, and then JavaScript is what we use to write the tests, right? So Truffle comes pre-bundled with a few different libraries that are really going to help us out when we write tests. The first is the Mocha framework. This allows you to create test suites in JavaScript. And the second one is the Chai assertion library. You can read more about these on their websites. Basically, Chai allows you to compare things like, saying a value should be a string or whatever. The assertion is the keyword here that you want to focus on, right? So let's go ahead and create our tests. So we'll go to this file and we'll create a test like this. We'll just say contract, right? And we'll paste in ethswap, and then we'll say accounts, all right? And then we'll pass in a callback function like this with an arrow. And this is where we'll write all the tests inside of here, all right? So in order to write tests against it, we must first import the smart contract just like we did in our migrations file.
Vamos a ir poquito a poquito. Contract swap. Accounts. Ey, aquí no. Aquí.
We can do it the same way in the test suite. So we'll just say token first, all right? So const token with capital T equals artifacts require token, and then contract ethswap, artifacts require ethswap. You can basically just copy and paste that directly from the migration file right here. All right, it's basically the same. So now we have these inside the project, or sorry, inside the test suite. The next thing we want to do is configure Chai, all right? Right, so that's the library I showed you a second ago. This is Mocha, and then this is Chai. So we'll configure the Chai assertion library like this. You can just pull this from the master project on GitHub, or you can code this out yourself. So we say require Chai, and we say use, do Chai as promised, and then should. Okay. So that's going to configure our assertions, which we'll observe later when we write the tests. Right. So the first thing I want to do is just create a really basic test that ensures that the smart contract was...
Esto no sé si va a funcionar, Require Chai. Use require. Sí, para que funcione quizá tengo que instalar eso de forma global. Bueno, ahora lo veremos cuando intentemos correr el primer test.
Deploy to the network. So first we'll say, and inside of here, we'll create our first test like this. We'll say const name equals await ETH swap dot name. All right. In order to do that equals await exchange. All right. So remember, this is what we observed in the console in the last video, and essentially we're just checking for that inside the test. So we can go to our terminal and run the test like this. We say truffle test, just checking for that inside the test. So
Esto no va a funcionar, ya os lo digo, pero bueno.
So we can go to our terminal and run the test like this. We say truffle test. All right, just make sure you have Ganache running like this. Oops, sorry. Like that, right? Okay, so we got a problem here. It says ETH swap is not defined. So what we need to do is say
Eso ya lo había visto. Cannot find chai. Cannot find chai. Vamos a ver la documentación que nos dice creating, running, interaction, truffle, testing. Testing in JavaScript. Aquí la verdad es que pasa de chai. esa línea se había colado. Test is not defined. Ok. Esto del expect creo que era de jest. Por lo tanto quizá vuelva a petar. Sí. Vale, pues lo dejamos así y esto lo dejo comentado. Bueno, voy a probar a descomentarlo a ver si funciona. Ahora tenemos test. Nada mal. Muy importante testear nuestros smart contracts para que nadie nos hackee. ¿Vale? La mayoría de noticias o cosas que dicen en plan han hackeado Bitcoin o han hackeado el no sé qué, no es que hayan hackeado la blockchain, sino que estos contratos están mal hechos y entonces la gente, más que hackearlos, simplemente pues explota funcionalidad que no debería estar, ¿vale? Entonces, muy importante testear esto. Chai, de momento no lo tenemos, así que
let ETH swap. Sorry about that. Try it like this. And boom, there we go. Our first test passed. So that's how easy it is to get started testing smart contracts. You know, we just fetched the smart contract and performed the operation that we did in the console in the last video. Like, imagine how long it would take you to open up the console and do that every single time. You can do this command and it does it automatically for you. And what we're gonna do in this tutorial series is, you know, create several more tests that would take us a really long time to check for in the console or maybe with the front-end application or something like that. So this saves a lot of time and gives you a lot of efficiency. And that's one really amazing thing about testing smart contracts. So a lot of people do test-driven development, and that's a really good practice. I think it's kind of challenging a lot of times for beginners. So we're not exactly going to be TDD, so to speak, in this video, but we are going to write tests. We're going to have test coverage for the basic functionality of the contract itself, okay? So now what we can do is write tests for the token as well, all right? So just like we described the ETH swap deployment, before that, I'm going to say describe token deployment. All right, then we'll say contract has a name, and instead of ETH swap, we'll just say token. All right, change both of these. And we'll say token. All right, and in this case, it won't be ETH swap, it'll be DApp token. And then we'll run the test like this. All right, so triple test, and hopefully it'll pass. All right, there we go. So the contract name is correct as well. So the next thing I want to do is make sure that the creation, sorry for that, is do is the so the contract.
Otra vez estaba muteado. Muy mal. He puesto otro test para asegurarnos del SensioCoin tenga el nombre adecuado. De hecho, esto... Es que esto está mal. Tiene que ir en otro archivo. Token has a name. Token... ¿Qué tiene que tener también? Symbol. SenCoin. Pasan los test. Bueno, ya os hacéis una idea, ¿no? De cómo testear simplemente que vuestros smart contracts tengan los atributos que tienen que tener. Ahora vamos a ver cómo testear que podamos hacer las transferencias y esas cosas, imagino.
Contract name is correct as well. So the next thing I want to do is make sure that the contract has tokens. All right. So remember we did that in the last video, basically in the initial migration, this migration, sorry. Number 2, we transfer the tokens to the exchange, to eSwap itself, right? And we checked in the console the token balance for eSwap, right? So we want to write a test that makes sure that that's also correct. So we can do that like this. We can say contract has tokens. Okay, and we'll say async. All right, just like we did before. And inside of here, let's just copy and paste this. All right. This, and we'll also say token new, right? So eSwap new. For that, we'll say token new. All right. And let's see here. So essentially what we're going to do is transfer the balance, just like we did here in the migration. Actually, she's going to copy this. All right. And do this. All right. And then say assert equal. Say balance, or actually, sorry, before we do that, let's check the balance. Say let balance equals await token, a balance of. All right, then pass in eSwap address, all right, and say assert equal. Just copy this value. Perfect. It's coded properly. We're about to find out in the basic test to start off with. You know, everything is deployed properly.
Vale, el siguiente test sería lo que hacemos en el deploy. Swap has all tokens. New. Token new. El total supply lo saco del mi token. Hago la transferencia. Saco el balance. Esto puede que pete, porque esto es un string y esto es un número. Vale, aquí tenemos el mismo problema de antes. Se me ha olvidado que el toString va con el await. Pues sí que pasa, oye. Qué raro. Uno es el número y el otro es todo esto. ¿Por qué dice que sí que son iguales? Si no lo son. Antes, cuando hemos sacado el total supply, hemos tenido que hacer algo más. Qué raro. O sea, esto va. Esto también. Pero esto... Esto debería funcionar también, entonces. Eso no va. Qué raro, oye.
Properly. Everything that we created in the last video is covered in the test suite. So before we continue, let's do a little refactoring. All right. The first thing is some duplication. So essentially, we're doing this twice. Token equals token.new. We're doing that here, and we're doing that here. But what we want to do is have access to the token in every test without having to write this code over and over and over again. And we also want to perform this operation where we transfer the tokens, once, so that we, the rest of the tests work like that. And also the same for, fetching the ETH swap contract. So what we can do is create something called a before hook, like this. So we say before, we say async, pass in a function. All right, and we can just put all the code that would be here inside of here. All right, that's the ETH swap. And we can say, just like this, transfer all tokens to ETHSwap. All right, and then we can take away all this. All right, and then we should be able to run the tests. It should work. Moment of truth. Okay, boom. We got a problem. And actually, I'm glad we ran into this problem because this is an important thing to highlight. It doesn't know what token is, and it doesn't know what ETH swap is. So there's a few different ways to handle this. Basically, it's saying when it gets here, it doesn't know what ETH swap is, and it doesn't know what token is. That's because these variables are declared inside this. There's a few different ways to handle this. How I'm going to do it is this. Say let token, and then I can say let ETH swap. All right, but I can also do this in one line like this. Boom, done. And take these away. And then now we have access to token and ETH swap inside these test examples. So I'll try it again. Hopefully it'll work this time. Awesome. Boom, it passes. All right, so the last thing I want to do is refactor this number. This looks kind of funny, right? So I'll explain how this works. You know, this might look confusing because this says this is 1 million tokens, right? That's how many tokens exist. But this number looks like a lot bigger than 1 million. So let me explain why. This token has 18 decimal places behind the zero. Okay, so I'll show you what that means. If you go to source, contracts, token.sol, obviously decimals is 18, all right? So what does that mean? Well, basically, like when you're talking about currency, let's take the US dollar, for example. You know, $1 is often expressed like this, right? 1 with a period or a decimal place, and then 2 zeros after it. Because, you know, a dollar has smaller subdivisions called cents, right? And 100 cents equals a dollar. So, you know, you can have fractional dollars like this. $1.99 is almost $2, but it's 99 cents. So whenever you're dealing with cryptocurrency and, you know, Ethereum smart contracts, you don't really deal with decimals, right? You basically have to express things as, you know, integers. So you can't use decimal places. So if you're going to write $1 as inside of an Ethereum contract, you have to write 100 cents like this. All right, this is how you would express $1 inside of an Ethereum smart contract. But for Ether, you know, the native cryptocurrency on the Ethereum blockchain and many tokens as well, they use 18 decimal places behind a zero. So, you know, one Ethereum or one Ether might look like this, and then do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? 18 decimal places. Well, that's what it looks like, all right? And you can't use decimals, so you have to take away the decimal place and do everything in cents, so to speak. C-E-N-T cents, right? Like cents, right? But in Ether, you don't call it cents, you call it Wei, right? That's the smallest Ethereum value is called Wei. So this is like what one Ethereum looks like in Wei value. So similarly, a lot of ERC20 tokens use 18 decimal places just like Ether does. So we can use the same standard for our DApp token that we created in this tutorial. So it's going to have 18 decimal places behind it. So that's what one DApp token would look like here. Now, if you want to talk about 1 million DApp tokens, you put, you know, 3 more zeros. So you just do like 1 million, 1, 2, 3, 4, 5, 6, and then you would copy this and paste it here. All right, and you'll see that's the exact same number. Boom, done. So that's what 1 million tokens looks like expressed in its smallest subdivision like this. All right, so that's really important to understand because we're going to use helpers in this tutorial series. For Ethereum, I'll show you. We'll create our own right now so that we can make this a little more human readable. I'll say function tokens in. All right, and what we're going to do, so I'll do that into Wei, which I just talked about a minute ago, where we'll say int. We want a human readable function that does that. So I'll do that right now. We'll say tokens, and we'll say return web3. We'll say new web3 utils. Actually, let's do this first. Web3 utils to Wei. All right, we'll say in, that's the number of tokens that we're going to pass in, and then we'll say Ether. All right, so Web3 is a library that we use to talk to the blockchain. We're going to see Web3 used a lot more in this tutorial, but essentially it has some utilities that allow us to convert Ethereum or Ether into Wei, which I just talked about a minute ago, where I showed you all those 18 decimal places and stuff like that. So we can use the exact same helpers for our token because it has 18 decimal places behind it, just like Ether does. All right, so we're not actually converting Ether, we're actually converting our tokens to Wei at the smart contract level or its smallest subdivision, but that's what we can do just like this. Okay. So we're going to use our helper, and instead of writing out this crazy long number, we'll say tokens, and then we'll pass in 1 million. 1, 2, 3, 4, 5, 6, and then we'll use it down here as well. Works, and there we go, it passes. Awesome, so we're gonna use
Vale, vamos a instalar esta librería, web3.js, colección de librerías que nos permiten interactuar con nodos Ethereum locales o remotos. Vale, como hemos visto en el tutorial, tenía una función, una utilidad para convertir de unidades ETH a los Weis, que son estos números con 18 decimales. Imagino que luego también pues podremos hacer muchas más cosas con esta librería. Vamos a instalar esto. npm install. Y por lo que comentaba, he hecho una función que en verdad tampoco es que tenga mucha utilidad, ¿no? Pero bueno. Tokens, le pasaremos un número de tokens y nos devolverá este web3 utils two way, ¿no? Algo así. Ahí me da el total supply. Vamos a asegurarnos, vamos aquí a hardcodear este millón. Aquí no está definido esto. Sin embargo, no puede encontrar web3.
Use this tokens helper so that we don't have to write out these really long strings every time. It's going to make things a lot more readable and a lot easier. Okay. All right. So that sets up our test suite. Now we can use this to start building out more of the smart contract. Okay. So the next thing I want to
Vale, había que pasarle el número como texto, ¿vale? Como string. Esto coge 1.000.000 de tokens y dice, vale, si estos son ethers, pásamelo a way, que es metiéndole 18 decimales, ¿vale? Esto funciona porque nuestro token sigue este estándar, ¿no? Con 18 decimales.
do is actually talk about the rate. So inside the smart contract, the next thing we want to do is actually import the token so that we can use it inside this smart contract. You know, essentially, we're going to talk to another smart contract from within this one. The two are going to interact with one another. So if we go back to our diagram, the eSwap exchange is actually going to talk to the DApp token smart contract. So in order to do that, we must import the DApp token contract into this particular file. So we do that like this. We do that with Solidity's import. And then we say dot, which is the current directory. I'm going to say token.sol. All right. So that's the same token file that we see here. So eSwap and the token. We're just importing token like this. So really quickly, we can just run our test. Oh, and also, we don't necessarily have to run the test. We can just do truffle compile to see if that worked. All right. So, and also, that we see here. So eSwap test, we can just do truffle compile to see if that worked. All right. So truffle compile is just a command that makes sure that the code has no syntax errors. All right. So that works. We don't actually have to go through the process of running the entire test suite just to see if our code is working properly. And you'll notice that truffle compile gets run before the test suite even runs. So it's kind of just a first line of defense to make sure that everything worked. Okay, so we imported the token. And then next what we want to do is keep track of the token in a smart contract like this.
Los puntos y comas me están dando
token, capital T-O-K-E-N.
problemas.
Say
Se me
public
olvida ponerlos.
token. And what this does is it creates a variable that represents the token smart contract. And later when we purchase tokens in this tutorial, we'll be able to call the token methods on this variable. Like transfer, for example. That's what's going to happen whenever we purchase tokens. We want to call this function, and we need to have access to it. All right, so we'll just like say token transfer, and we'll use this particular variable to do that. All right, so next what we need to do is tell this smart contract where this particular contract is located. So what we're going to do is create a function that gets run whenever the smart contract is deployed to the network. Call it constructor. And say public. And inside of here, we're going to basically set the token up. So when we say token like this, when we import the smart contract, it's just the code for the smart contract. It doesn't actually tell us where it is on the blockchain. All right, so remember like when we did the truffle console, we saw that the token had an address, just like the accounts do, like the smart contracts will have addresses that look like this. Well, we also need that to use the smart contract inside of here. We need the code for the smart contract and then the address, okay? So what we can do is pass the address in whenever we deploy the token to the network. So we can say token, and say token, T-O-K-E-N, all right? And then say token equals underscore token, all right? So I use underscores here as a naming convention, and it also helps conflict from this right here. All right, so that gives us a token that we can actually interact with later inside of here. All right, so also let me stop and explain a couple more things. First is how these variables work. So this right here is called a state variable. Name is a state variable because the data that's stored in the name variable is actually stored on the blockchain. That's why we were able to go to the console and also the tests and fetch the variable name value for name, right? So in the same way, we want to store the token on the blockchain. But this right here, this is just a local variable, all right? It's actually a function argument that we access with the local variable here. And this doesn't get stored to the blockchain unless we do this, all right? So that's why we assign token right here, okay? So this is just a variable we could do other stuff with in our function. We'll see that more later. But this actually writes to the blockchain because it stores to the state variable, okay? So we'll see other properties of state variables. Like for example, they can be accessed in other functions where this variable right here can only be accessed inside of this particular function, right? And again, this constructor function, this is a special function with the constructor keyword inside Solidity that gets run once and only once whenever this contract gets deployed to the blockchain. We can't like call this function, for example, inside a test, right? Because we added an argument here, we have to do a couple things, all right? First, we have to update the migrations whenever we deploy the token to the blockchain. So if we go to initial migrations, or sorry, deploy contracts, we have to tell it the token address, all right? That's why we did this first. So what we do is pass in the argument for this constructor function right here, token with token address, like this. Say token.address. All right, so let's try to migrate the contracts again. Truffle migrate -- reset. Remember, we need to deploy a new copy to the blockchain. All right, it worked. So the next thing we need to do is go to the test, and we want to pass in the token address there as well. All right, so essentially what we do is just modify what we have already. All right, we just go here, ETH-swap, and say token address. All right, and that makes the ETH-swap contract. Oops, sorry. Test. That makes the ETH-swap contract aware of the token inside the test as well. It provides the necessary constructor argument that we need to move forward. Okay, so let's keep building this out. Make sure the test pass first. Yep, all good. The next thing we want to do is go ahead and create a way to buy the tokens. So we'll create a new function inside the smart contract like this. We'll just call it buy tokens. We'll say function. All right. We'll give it a name. Say buy tokens. And we'll do these parentheses like this. And this is where we're going to write all the code to purchase the tokens. So inside of here, what we want to do is essentially just transfer tokens from the ETH-swap contract to the person who's buying them. All right. So we're going to rely upon the transfer function, right? This function in here from the token. And we just call it like this. We basically just say token.transfer. And then that will send the tokens from the token contract, sorry, ETH-swap contract to the person who's purchasing them, right? Whoever's calling this function. But we need to pass in a few arguments. We need to tell it who it's going to, and then also the value. Okay. So how do we determine that? Well, the recipient is going to be the person who called.
Buy tokens.
Calls this function, right? And inside of Solidity, we can find out who that is like this. We say msg.sender. So let me explain that. MSG, or message, is a global variable inside of Solidity, and sender is the value of the address that's calling this function. So, for example, something like this. Okay. So that's the first argument, who the tokens are going to. And then next we want to determine the value. So you could say like, one token followed by, 18 decimal places, yada, yada, yada. But we actually want to calculate this value out, all right? So how do we do that? Well, we know that we're sending in Ethereum, or Ether, the cryptocurrency on the Ethereum blockchain, in order to purchase tokens. If we go back to our finished application, that's what we do. We buy the tokens here with Ether, right? So that's what's going to happen is the person calling this function is going to be sending in Ether, and they're going to buy tokens. So what we want to do is determine how many tokens they purchase based upon the Ethereum amount that they're sending whenever they call this function. All right. So if we go to our finished app here, we see that 1 Ethereum equals 100 DApp tokens. So we have to perform this calculation. All right. So what we're going to do is just create a variable here. It's called token amount. All right. We'll make a calculation. So the token amount is going to look like this. We can just say uint. So this is going to stand for an integer, an unsigned integer. The token amount. All right. It's going to equal something. So what's it going to equal? Well, basically what we want to do is say amount of Ethereum multiplied by the redemption rate. Okay, so all right, so the redemption rate equals number of tokens they receive for 1 Ether. All right, in this case, that's going to be 100. Right, so if you go back here, you say 1 ETH equals 100 DApp. So what we're going to do is create a state variable inside of here called rate. Say uint public rate. Right, and we're actually going to assign the value right here in line. Call it 100. All right. So I'll pause really quickly and also say this uint stands for unsigned integer, okay? Which basically means, 100 is an integer. It can't have decimal places. And unsigned means that it can't be negative, all right? It means it can't have a sign in front of it like this, okay? Okay, so same for this. Uint token amount has to be a positive integer, all right? So here's the redemption rate. The number of tokens they receive for 1 ether. That's going to be the rate. All right, and then what we're going to do is find the amount of Ethereum and multiply it by the redemption rate. So how do we find the amount of Ethereum or ether? Just like msg.sender, we can do it like this, msg.value, all right? So what that does is it is another global variable that tells us how much ether was sent whenever this function was called, all right? So it's a special reserved keyword inside of Solidity, but this is going to tell us how much ether was sent whenever the function was called. So we can take that value and just multiply it by the rate, all right? So it's pretty straightforward once you understand the basic concepts, okay? So now we can say, calculate the number of tokens to buy. Let me take this out, take this out, take this out. So quick recap, we're just calculating the token amount, we're taking the Ethereum amount, multiplying it by the rate, the number of tokens when they contribute 1 ether, and then we call the token's transfer function. We say msg.sender, that's who we're sending it to, the person who's calling it, and then we're passing in the token amount, which we calculated here, right? So we see that, 2 in value, and that's 2 and value. All right, so the last thing we need to do to this function before we can try it out is make it public, so that it can be called outside the smart contract, and then the next thing we need to do is make it payable. All right, and that's going to allow us to send Ethereum whenever we call this function, right? So if we didn't have this, we wouldn't be able to send Ether whenever we do it. Okay. So there's going to be a little bit more to this, but that's the basic functionality for now. We can run a test against it. So let's just try to compile the smart contract first, truffle, compile, see if this works. And if it does.
Vale, pues lo que hemos hecho, básicamente en el contrato este del ETHSwap, ¿vale? El smart contract que se va a encargar de hacer el exchange entre Ethereum o ETH y Sensio-Coin, ¿vale? Y hemos añadido varias cosas. Lo primero que hemos añadido es una variable token, ¿vale? Y aquí hemos importado nuestro smart contract del token, ¿vale? Como veis, desde un contrato inteligente podemos importar otros contratos inteligentes, ¿vale? Entonces, tenemos un token de tipo token y público, y además hemos definido esta rate, ¿vale? Esto es lo que nos va a decir cuántos ETH vale un Sensio Coin, ¿vale? En este caso, 100 Sensio Coins van a valer un ETH, ¿vale? De forma que cuando alguien quiera comprar estos tokens, bueno, aquí en el constructor lo que hemos hecho es inicializar este token, ¿vale? De forma para que esto funcione, ¿no? En el deploy, ¿vale? Ahora cuando hacemos el deploy del ETHSwap le pasamos la dirección del token. Como veis, el deploy del token se hace antes, y en los tests también lo he cambiado a medida que lo estaba explicando el tío. Y luego tenemos esta función para comprar tokens, ¿vale? Tiene que ser pública para poder acceder a ella desde fuera, y payable, ¿vale? El payable este hace que se pueda pagar. Entonces este mensaje, ¿no? La dirección que ejecuta esta función tiene una dirección que es este sender, no sé si debería ser address, quizá, bueno, luego lo veremos, y un valor, ¿vale? Estos son los ethers que está enviando. Lo multiplicamos por el rate, que son 100, ¿vale? Entonces si alguien llama a esta función pagando un ether, ¿vale? Se le va a hacer una transferencia de 100 Sensio Coins.
This will continue on with the test. All right, that worked. So let's write the basic test for that functionality. And we'll say describe, so we'll minimize this. And say describe. I'm going to give myself some space here. Say buy tokens. We're going to write all the tests for this function here, say async. All right, and we'll say it allows user to instantly purchase tokens from ETHSwap for a fixed price. Say async. All right, so inside here what we want to do is basically just say, ETHSwap, buy tokens, all right? And then we want to pass in the person who's purchasing them. So how we do that is basically tell a specific account. So you can see this accounts right here. We can say accounts 1, say from accounts 1. And then what we also need to do is not just tell who it's who's calling the function, but we also want to say how much ether that they're sending whenever they purchase the tokens as well. Okay, so we do that with value. All right, and let's say they want to contribute 1 ether. So we tell it 1 ether, followed by 18 decimal places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Remember, we can't use decimal places, so we have to create a value like this. But that would be the basic, functionality. We can just say await, ETHSwap, buy tokens. So that's not going to check for anything, but let's just see if it works to make sure nothing broke yet. All right, so buy tokens is not a function. Let's see here. All right, so looks like I had a little error. Let's go back to our code here. Capitalize the T. So that's my fault, everybody. Buy tokens should be have a capital T. Let's go back here. All good. Let's try it again. Triple test. See if it works. And boom, there we go. So it doesn't actually check for anything yet. I just want to make sure that this was configured properly. So let's refactor this before we move on. Instead of coding this out long form, we're going to use utility. We're not going to use tokens like this. We're going to say this. All right, let's try it again. Remember, tokens work like that, but we're going to say to way from ether, because we're actually sending an ether here. Oh, so in, sorry. We're going to do 1 ether. All right, and the next thing we're going to do is refactor this account so that we're not always like reading out of this array. So we're going to use 2 users in this case, right? And you can actually break this out inside the test suite. Instead of returning an array here inside this callback function, we can actually fetch accounts out individually by declaring an array and say say deployer as the first account, and then investor. Okay, so deployer is going to reference the first account inside Ganache like this, right? That you can see their balance keeps going down, and then the second account will be the investor. Okay, we can see their balance has also gone down because they just called the buy tokens function. So it actually went down by 1 ether each time we ran it. So now we say investor here on the test. See if it works. Boom, there we go. All right, so the next thing is to explain, from and value. So this from on the test. So it actually went down by 1 ether each time we ran it. So now we say investor here on the test. See if it works. Boom, there we go. All right, so the next thing is to explain, from and value. So this from here is going to correspond to msg.sender, all right? We specify the address. And then the value here is going to represent, let's see, here we go. The msg.value, okay? So this corresponds to from, and this corresponds to value. Just like this. I'm going to take this away. All right, so now, before we continue on with this specific example, let's refactor this into a before hook, just like this. So inside of here, we're going to do this. Say before. Okay, and we're going to move this inside there. Before we continue on with this specific example, let's refactor this into a before hook, just like this. So inside of here, we're going to do this. Say before. Okay, and we're going to move this inside there. All right, and we're going to say result. And we're going to say let result. Okay, and we'll say purchase tokens before each example. And so inside of here, what we want to do is just check that the balance actually changed. So we're going to check that the investor received the tokens. So we'll say investor received tokens after purchase, right? And we can just check for the investor balance like this. We just say, let investor balance equals wait, token balance of, and say investor. And then we check it, say assert equal investor balance, toString, tokens 100. So let's try that. See if it works. Boom, there we go. Awesome. So that's the basic functionality. So the next thing we want to do is check the ETH swap balance. We're going to make sure that it lost tokens. It lost 100 tokens. So
ok. Vale, pues cuando queremos comprar tokens, tenemos esta función buy tokens que acabamos de hacer, y a esto le pasamos un objeto, ¿vale? Y el from corresponde con el message sender y el message value corresponde con este value. Entonces decimos compra tantos tokens como un ETH que te vamos a enviar. Entonces ahora podemos mirar el balance del investor y asegurarnos que este balance sea igual a 100, ¿vale? Porque un Ether corresponde a 100 Sensio Coins. Y esto ha fallado. Esto está bastante mal, ¿no? Esto del deployer investor, no sé si lo he hecho bien. Contract, deployer investor, sí, esto está igual. Pero me sale aquí como si el investor fuese el primero, no el segundo. Si os fijáis, el balance del investor es todos los tokens. posible que esto esté al revés. Este creo que no está bien,
Down this callback function. T. So back here, capitalize the T. That's my fault, everybody.
¿Cómo es posible que el token tenga que transferir si todo el dinero se los... O sea, todos los tokens se los hemos dado al Let's Swap? Hay algo aquí que me baila. Según console log del balance me dice que es 0. Y si le hago una transferencia, ¿qué me dice? ¡1 millón!
string. Balance. We're gonna make sure that it locks.
Ah, vale, claro. Estaba olvidando de esto. Ahora sí. Vale, y he visto en el ganache que me baja el número de la dirección 2, el que ahora le hemos llamado investor, pero cuando acaban los test los vuelve a reponer, lo vuelve a poner a 100.
Lost tokens. It lost 100 token balance of. All right, pass an eSwap address. All right, and then we'll check it. We'll say, boom, there we go. Should be that many once we subtract 100. And then say, yeah, there we go. Should work.
Vale, y ahora testeamos. Que el balance del ETH swap sea $1.000.000 menos 100.
Pass in tokens, and then the number of tokens should be that many once we subtract 100, and then say.
Así que ponemos otro número, esto debería petar.
Yeah, there we go. Should work. Let's try the test. See if it passes. Oh, boom, there we go. eSwap balance is strings on our function. So let's see here. eSwap balance. Okay, I see the problem here. I just missed an in. All right, save that. Try again. So sorry, I'm full of typos today, everybody. We can say ETH swap balance equals await web3 equal ETH swap balance string. And we can say web3 utils 2-way 1 ether. Let's also do that. See if it works. Okay, we got a problem here. I just mistyped this. eSwap address. Sorry, everybody. Try it again. Hopefully this will fix it. See if it passes. All right, there we go. Works. So we can see that the token balance went down and the eSwap exchange received 1 ether. All right, so the ether left the. All right, there we go. Works. Hopefully this problem here. I just mistyped this. eSwap address. We can say assert. We can say I just missed an in. All right, save that. Try it again. So sorry, I'm full of typos today, everybody. All right, boom, there we go. So the next thing we're going to do is check that the ether balance went up. So we can do it like this. We can say ETH swap balance equals await web3 ETH get balance. This is the function that we use to check the Ethereum balance. ETH swap balance. All right, we can say assert equal ETH swap balance string. And we can say web3 utils 2-way 1 ether. Let's also do that. See if it works. Okay, we got a problem here. I just mistyped this. eSwap address. Sorry, everybody. Try it again. Hopefully this will fix it. See if it passes. All right, there we go. Works. So we can see that the token balance went down and the eSwap exchange received 1 ether. All right, so the ether left the user's account, the investor's account, and went to eSwap, and the investor got tokens. All right, and then the token balance for the eSwap exchange went down, just like we expect. All right, in our finished application, the investor goes here, and basically they just put in 1 ether, and they got 100 tokens. They click swap. The exchange, or eSwap in this case, gets 1 ether, and they dispense 100 tokens, and the token balance goes down. While we're here, I want to do one more thing. I want to teach you about events inside of Solidity. Ethereum.
Vale, entonces el investor compra 100 tokens. Los 100 tokens desaparecen del exchange. El exchange ha recibido un Ether.
Ethereum allows you to emit events from your smart contracts. Essentially, they're a way of subscribing to events in the blockchain and finding out that something happened. So in this case, what we want to do is trigger an event that tokens were purchased, right? So we'll say emit an event. So basically, we want people to subscribe to this and say, oh, a token was purchased. And it's going to allow them to do lots of different things. We'll be able to inspect the value of how many tokens were purchased and things like that. It'll show you in the test, okay? So we do like this. First, we need to define an event. It's pretty easy. We can just do it at the top of our file like this. We say event token purchased, all right? And add a semicolon like that. And we can add some arguments to the event. We say address, count. That's going to be who is calling the function, who purchased the tokens, address, token of the token that was purchased. We'll say uint amount, the amount of tokens that were purchased, and then uint rate, the redemption rate that they purchased the tokens with. So basically, someone, if they had this information, could make like a transaction history or something like that, and determine the exact amount that was purchased and all that kind of stuff, and how much ether they sent. So that's why you do something like that. So it's really easy to emit the event inside of the function. We just say emit token purchased, right? And so the account is going to be msg.sender, all right, just what we did here, and then the address is going to be the token, all right, for the token right here. But we must convert this to an address like this. Okay, and then the next thing is going to be the amount, just token amount. Just copy this and paste it here. And then finally, the rate is going to be the rate they purchased it with here. All right, and then we'll just do a semicolon at the end of the line. So let's just run the test again, make sure they didn't break anything. All right, should work just fine. All right, pass, perfect. So now what we want to do is actually inspect this event inside the test to make sure that it return the arguments we expect. So what we can do is go back here and inspect the event like this. I'm just going to log into the console first so that you see how we find it. Essentially, all right, pass, perfect. So now we want to
eventos. Emitimos un evento cuando alguien compra tokens. Definimos un evento así, tal como teníamos de hecho en el otro contrato, el del token, que teníamos eventos. Alguien ha comprado tokens. Aquí tenemos la dirección de quien lo ha hecho. La dirección del token, la cantidad y el rate.
What we want to do is actually inspect this event inside the test to make sure that it return the arguments we expect. So what we can do is go back here and inspect the event like this. I'm just going to log into the console first so that you see how we find it. Essentially, we're going to use this result that was returned after we called the function, and we'll just say const event. We'll just say this console log, and we'll say result.logs. All right, this is the logs that come back from the function call. We'll run the test again to see what that is. It'll just show it here on the screen when the test is finished. We'll be able to see what that looks like since we did a console log. All right, boom, there you go. So this is what the log looks like. So it's got a bunch of different properties here. It's got like the ID, the address, all that kind of stuff. But if you look at the args and then the result, you can see these values: account, token, amount, and rate, which we defined inside the event. So the event gives us some history of the data that was sent in with the function. That's one of the reasons we do this. All right, so we can write a test to make sure these values are right. We just dig into this object by saying result, logs. We'll get the first one, so say 0, and then .args. All right, so let's run the test again, see what those are. That should just give us this set of values here. All right, boom. So now we can call account, token, amount, and rate on this directly. So we'll say const event equals this, right, what I just showed you. Say assert equal. I'm just going to do this really quickly. Boom. Assert equal. The event account is the investor, right? The event token is the token address. The amount is 100 tokens, and the rate is also 100 tokens, right? So copy this. You can pause the video if you want to see all that code and understand it more. I'm going to run the test and see if it works. All right, it passes. Perfect. So the last...
Este resultado era... esto, ¿no? Y ahora nos tenemos que asegurar que el account sea el investor. La dirección del token. Esto fallado. ¿Qué más? El event amount to string es igual a los 100 tokens. Y por último, el evento tenía el rate, que también hemos dicho que era 100, ¿no? Ok.
Last thing I want to do before we wrap up this section is create a requirement. All right. So essentially, what we want to do is require that this exchange actually has enough tokens. So if someone like tries to purchase it, like then if someone tries to purchase more than the exchange has, then it'll fail. All right. So basically, we're going to say require token, a balance of. All right. So address this is greater than or equal to token amount. All right. So essentially, that means if somebody tries to buy more tokens than the exchange has, then this will fail. So I'll break that down. Require is just a statement inside of Solidity that will say, hey, if whatever you pass into here, if it evaluates to true, keep executing the function. If it evaluates to false, stop executing the function and don't do anything else, okay? And throw an error. Okay, so we can check the balance of each swap inside this function by saying token balance of, right, that fetches the balance, and then this references the address of the smart contract. So this is actually each swap's address, okay? And we convert it to an address type like this, right? So basically we just say, make sure that balance is greater than or equal to the amount of tokens that are getting purchased right here, all right? So make some notes about that. So we'll say require each swap has enough tokens, and then we'll also make a note here that this transfers tokens to the user, right? So I'm gonna save that, run the test again, see if it passes. And hopefully nothing changed and the test will still work. All right, there we go. So, we could write a test for this, but I'm going to skip it for now, and I'll explain why. Basically, I would have to have 1 million ether, or close to 1 million ether in order to, I guess I'd have 100,000 or 10,000, something like that, right? A lot of ether in order to purchase all the tokens in each swap or more. But I don't want to really simulate a test scenario where that's possible. I'm just going to trust that this works for now. We're going to test out other requirement statements in the next video, so you're going to get plenty of practice on that. But for now, I'm just going to leave this as is, the test pass, and we're going to stop there for now. Okay, so let's continue.
Y lo voy a dejar aquí yo también, gente. Llevamos casi 3 horas de directo. Hemos hecho muchas cositas, hemos aprendido mucho. Y el próximo día pues seguiremos. Vale, ya hemos creado nuestra Sensio Coin. La hemos puesto en una blockchain de prueba, de test. Y estamos ahora haciendo el exchange para poder comprar estas Sensio Coins a cambio de Ether, la moneda de Ethereum. Y nada, a ver, por lo que veo aquí hemos hecho hasta aquí, hasta la parte 2. Y nos falta pues ver cómo acabamos de hacer, cómo comprar estos tokens, pues hay que ver cómo venderlos. Y luego, por lo que parece, ya empezaremos a hacer la aplicación, el frontend. Esto será bastante diferente a lo que hace él. Bueno, ya me he visto un poco el tutorial y él lo hace simplemente con React. Nosotros lo haremos con las herramientas que conocemos de los otros vídeos. Y ya estará, porque luego me parece que es simplemente un tutorial del lenguaje de programación de Solidity. Así que nos quedamos hasta aquí. Pues yo creo que en otro stream como este, quizá, pues lo acabaremos y tendremos desplegado nuestro exchange para comprar Sensio Coins a cambio de Ether. Pues nada, muchas gracias. Nos vemos el próximo día. Chao, chao.